Hi everyone, in this video we will see the operation of a single phase to single phase step cycloconverter bridge type. The circuit consists of a total of 8 ACRs, P1 to P4 and N1 to N4. 4 for positive group, the P1 to P4 ACRs are the positive group and remaining 4 ACRs for the negative group. When B is positive with respect to C, during positive off cycle of AC input from 0 to pi, P1 and P2, the SCR P1 and P2 are forward biased and N1 and N2 are forward biased. So at omega t is equal to 0 to pi, you can say that the P1, P2 are forward biased and N1, N2 are forward biased. So if you look at the circuit, when P1 is conducting, it carries the current through P1 and goes to the load, and P2, then it will come out like this. During negative, on the right hand side, the negative group, this N1 and N2 are conducting, so the B is made positive and the current is flow through N1, load, and N2, and it will come out like this, right? So when P1 and P2 are turned on together at omega t is equal to 0, the load voltage is positive. This is a load voltage waveform. The load voltage is positive with the terminal A is positive, okay, with the respect to 0. So the 0 is made as negative. The load voltage now follow the positive envelope of the supply voltage. This is a load voltage. Simply it follows the positive envelope of the supply voltage. So I can see that the output voltage and the output current both are positive when the thyristor P1 and P2 are turned on together at omega t is equal to 0. At instant omega t1, the SCR pair P1 and P2 are turned off, right, by a forced commutation, and forward bias the SCR pair N1 and N2. So the N1, N2 is conducting. So with this, the load voltage is negative. If you look at the waveform, the load voltage is negative with the terminal O positive and A is negative. So this is A is negative and a terminal O is positive. So the load voltage now follow the negative envelope of the source voltage like this. At instant omega t2, N1 and N2 are turned off by a forced commutation and P1 and P2 are turned on. If you look at the waveform, the P1 and P2 are turned on. So the load voltage is now positive and it follows the positive envelope of the source voltage. So after omega t is equal to pi, the thyristor pair P3 and P4 and N3 and N4 are forward biased. So these can be turned on and forced commutated from omega t is equal to pi to 2 pi, right? So in this way we can able to get the high frequency turning on and the forced commutation of pairs P1, P2, N1, N2 and pairs P3, P4 and N3, N4 will use a carrier frequency modulated output voltage across the load terminal. Thank you.